So we'll discuss in this concept what is determinant, how it is derived, where we'll use these determinants, how to expand the determinant. So these concepts would be discussed in this chapter. So let us see first what is determinant. So define this determinant. We should recall the pair of linear equations in two variables. Let us take a1x plus b1y equal to c1 and a2x plus b2y equal to c2. So as we know that this pair of linear equations can be expressed in the form of matrix. So this is a1 b1 a2 b2 multiplied by matrix xy. The resultant is matrix c1 c2. Actually, the determinant determines the uniqueness of the solution associated with this matrix. So, uniqueness of these solutions, when these two solutions are having unique. So, recall the unique solution. When the pair of linear equations has unique solution. When the pair of linear equations has unique solution.
When the two lines intersect, they have a unique solution.
Right, very good. So, what is the condition would be satisfied?
When they both are not equal.
Which both are not equal, ma?
A1 by A2 is not equal to B1 by B2.
Very good. So when a1 by a2 is not equal to b1 by b2, then the pair of linear equations has unique solution. So from this, if we cross multiply this, this is a1 b2 is not equal to a2 b1. That implies a1 b2 minus a2 b1 is not equal to 0. When this value is not equal to 0, then we'll say that the pair of linear equations has unique solution. So the left side part a1 b2 minus a2 b1 is maybe a real or complex number. The real or complex number of a1 b2 minus a2 b1 is called determinant of this matrix a1 b1 a2 b2. The determinant of matrix a1 b2 a1 b1 and a2 b2 can be expressed as a1 b1 a2 b2. We'll use these two parallel lines to represent the determinant. So this is called a determinant. It is denoted by either delta or D, capital D. Or if suppose name it as matrix A, this is also read as det A. So the value of this determinant is a1 b2 minus a2 b1. This is the expansion of this determinant, and the resultant value is called value of determinant of A. Do you understand? Therefore, det A equal to a1 b2 minus a2 b1. Is it clear? So let us take two equations a1x plus b1y equal to c1, a2x plus b2y equal to c2. As we know that these two are pair of linear equations, the pair of linear equations has unique solution when the condition is satisfied a1 by a2 is not equal to b1 by b2. From this we can write it as a1 b2 is not equal to a2 b1. This implies a1 b2 minus a2 b1 is not equal to 0. So when this value a1 b2 minus a2 b1 is not equal to 0, then only the pair of linear equations has unique solution, isn't it?
Yes, sir.
So this value is, if you simplify that a1 b2 a2 b1 are coefficients, so we'll get either real value or complex number. So this pair of linear equations can be expressed in the matrix form, the coefficients a1 b1 a2 b2 into matrix xy. The resultant value is matrix c2. So this a1 b2 minus a2 b1 is called the value of determinant of this matrix. So this matrix can be expressed as a1 b1 a2 b2 in this format, or use two parallel lines. Then we will say that it is a determinant. So the value of this determinant is a1 b2 minus a2 b1. So suppose if we represent this matrix by A, then it is denoted by either delta or det A. But you should not think that we are using parallel lines, so it's a modulus. It is not modulus. It's not absolute function. It is a determinant. So the expansion of the determinant of a1 b1 a2 b2 is a1 b2 minus a2 b1. Is it clear, ma?
Yes, sir.
Yes, sir.
It is only square matrices have determinants. The determinant of matrix A is denoted by using these parallel lines. This is read as either determinant of A det A, or it is also denoted by delta. But it is not absolute value. Right? So here the first one is determinant of first order matrix is for example, take matrix A is it has only one element A. Then det A is A only. The element itself is the next one is determinant of second order matrix. That means 2 by 2 we need, right? So let A is a matrix 1, 2, 3, 4. Then the value of determinant of A. Det A is a1 b2 minus a2 b1, right? So first multiply these two. 1 into 4 minus multiply these two. 2 into 3. So the value is 4 minus 6. So it is minus 2. Usually det A first will represent it as determinant of 1, 2, 3, 4. Then you can multiply these. So when matrix A is 1, 2, 3, 4, therefore the determinant of A is minus 2. Is it clear?
Yes, sir.
Easy to understand. Second order determinant. If you go to the third order determinant, we'll expand the determinant using along a row or column. Out.
No, sir, noting it.
Okay. Determinant of order 3. So determinant of matrix of order 3. So let us consider an example. A is suppose 1, 2, 1, 2, minus 3, 4, 0, 1, minus 2. Then find if A is this matrix, then find that A. So first of all, that A is we can express it as 1, 2, 1, 2, minus 3, 4, 0, 1, minus 2. We can expand this determinant either along any one row or any one column. First, recall the signs, how to put the signs. If it is first order determinant, there is no doubt only plus or minus. What is the value is given in the element, the same value will get it. If it is second order determinant, this is plus, minus, minus, plus. So if it is third order determinant, the signs are the first element has plus, minus, plus, alternate signs. This is plus, minus, plus. So where we'll use this, we'll see that in this expansion, suppose expand this determinant along R1. If it is along R1, we should select this, right? So what is the first element in R1? 1. So let us write 1. 1, the first element has plus sign only. So first plus we need not write. So we'll write it as 1 into, delete this row along with 1 and delete this column along with 1. So what are the remaining we have? So the remaining is the determinant of minus 3, 4, 1, minus 2. Right?
Yes, sir.
Next.
Yes, sir.
The next sign is minus. So we'll take minus. The second element selected. The second element is 2. So we'll write 2 into, we should delete this row along 2 and we should delete this column along 2. So what is the remaining value? The 2 by 2 determinant is 2, 4, yes,
Minus 2.
0, minus 2. What is the next sign we have to take?
Plus.
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 Yes, no, plus. So we should go to the next element. Next element is 1. What is the element is given? We'll write as it is. Multiplied by, delete this row and column along with 1.
So 2 minus 3 0 1.
Yes, ma, very good. So this is 2 minus 3 0 1. That's it. If we simplify that, we'll get the result, ma. This is the way we have to expand the determinant along R1. If you want to change along R2, R3 also, we can use the same. We'll use this order of the signs. If it is R2, first one is minus, next one is plus, next one is minus. Is it clear?
Yes, sir.
The same can be applicable for column also. You can find the determinant value expanding along C1, C2 or C3 also. Now this result is 1 into, we know that this expansion, right? We should multiply these two. minus 3 into minus 2 minus multiply these two, 4 into 1 or 1 into 4. The next one, minus 2 times of these two multiply, 2 into minus 2 minus these two, 4 into 0 or 0 into 4. So this expansion also over. Then plus 1 into these two multiplied, 2 into 1 minus multiply these two, minus 3 into 0. Is it clear?
Sir. Sir.
Yes, sir.
So this is 1 into multiply these two, plus 6 minus this is 4, minus 2 times of this is minus 4, this is minus 0, plus 1 into this is 2 minus of minus whatever it is 0 only. So this, tell me. What's your doubt? So she called me so that I asked. Okay, 1 into this is 6 minus 4 is 2 minus 2 times of this is minus 4 plus 1 into 2. So the result is 2 minus into minus plus 2 4s are 8 plus 1 2s are 2. So that the answer is 12. So the determinant of this value is 12. Is it clear?
Yes, sir.
So this is the way we can expand any 3 by 3 matrix. Even if it is 4 by 4 also can be expanded. But in our in 12th standard level, we'll discuss in 3 by 3 matrix. Matrix.
So for third order matrix, can we take by ourselves, or they will mention in the question we should take along R1 or R2?
If it is mentioned, we should take the same. If it is not mentioned, we can take any one.
Okay, sir.
So evaluate this determinant. So how to find this result? First we should multiply these two. 2 into minus 1 minus multiply these two. 4 into minus 5. So it is minus 2 minus into plus minus minus into minus is plus. 4 5 is 20. So that the answer is 18. So the value of this determinant is 18. Do you understand it?
Yes, sir.
Yes, sir.